In this short tutorial, I've prepared for you 3 examples on how to solve equations containing radicals. Each of these questions differs in difficulty, so let's begin with question number 1 being the easiest. So we have the equation the square root of x minus 5, that's underneath 1 square root, minus 4 is equal to 0. The very first thing that I will do is bring this negative 4 over to the right side. Watch what happens. We have x minus 5, that doesn't change, is equal to 4 being positive. Next, I will try to get rid of this square root by squaring both sides. That's what eliminates a square root. So by squaring both sides, I end up with x minus 5, now without the radical symbol, and 4 to the power of 2 is 16. Bringing over this negative 5, so that we group the like terms, we get x is equal to 16 plus 5, and that is 21. Now, whenever you do these types of problems, you do want to check your answer. So I'll take this 21 and substitute it back into there, and I need to make sure that the left side and the right side are in agreement. If they are not in agreement, then even though we've solved for x, it is not a solution, and no solution actually exists. So we have 21 minus 5 minus 4 is equal to 0. Let's find out what that is equal to. 21 minus 5 is 16. The square root of 16 is 4, and 4 minus 4 is 0. So this is a solution. Moving on to the medium level question, we have the square root of x squared minus 6x, that's on the left side, is equal to x minus 9. So again, I'll use the same technique as before. I'll square both sides of the equation so that I can eliminate the square root, and that opens up the terms on the inside called a radicand. So squaring a square root gives us x squared minus 6x, and on the right side we have x minus 9 squared. I will expand that, x minus 9 and x minus 9. We get x squared minus 9x plus 81. So we're multiplying two binomials here, and these are the arrows to show the sequence that I used to get that expression. And that reduces down to x squared minus 18x plus 81. So that's the right side of the equation. X squared minus 6x is the left side. And you'll notice that we have an x squared and an x squared on both sides, so they cancel out. And now I will group together like terms, so I'll bring that negative 18x to the left side. Negative 6x plus 18x makes 12x. And then dividing both sides of the equation by 12, we'll isolate for x. We get x is equal to, notice that the 12's cancel out, 81 over 12, and that reduces to 27 over 4. If we substitute 27 over 4, which is equal to 6.75, into our equation, watch what happens. And please pay attention to this because it's important. So if I have the square root of 6.75 raised to the power of 2 minus 6 times 6.75, and I substitute 6.75 on the right side, now let's calculate this. We have the square root of 6.75 to the power of 2 minus 6 times 6.75. That gives us 9 over 4. But on the right side, 6.75 minus 9 is negative 9 over 4. Therefore, because they do not match, the left and the right side do not agree, then what we found for x is not a solution. And this equation has no solutions. Just keep that in mind for future reference. In question number 3, we have the hardest being the square root of x minus 32 plus the square root of x is equal to 16. Now, oftentimes when you're doing these problems, you might need to take some time to think about a strategy. For me, I will take the square root of x to the right side. So I have the following, 16 minus the square root of x. And again, I'll use the same strategy as question 1 and 2, where I square both sides. This leaves me with x minus 32 on the left side. And on the right side, I have a binomial here, 16 minus the square root of x being multiplied twice. So let's see where that takes us. 16 times 16 is 256. 16 times negative square root of x is 16 square root of x. Again, negative 16, the square root of x. And the square root of x times the square root of x makes x. So I have 256 minus 32, the square root of x, plus x. This x and that x will cancel out. They're the same symbol on opposite sides. I'll bring this 256 over to the left side so I can group it together with the other constant, the negative 32. And on the right side I have the following term. So I'll combine negative 32 and negative 256, which equates to negative 288. I'll divide both sides by that coefficient of negative 32. So using our calculator, negative 288 divided by negative 32 makes 9. So I have 9 is equal to the square root of x. I'll square both sides to isolate for the x, and I get 81 is equal to x. Now substituting 81 in for this x and for that x will output an answer of 16, which means that this is a solution.